Great. So let's start with who we are and where we work. So we're a newer team within GitHub called GitHub Next. You'll see some things out there that reference GitHub Octo. That used to be our old name. So if you see that out there, it's the same team, GitHub Octo, GitHub Next. And the purpose of our team is to explore the future of software development. It's incredibly vague and a big mission, but we try to do that concretely by creating new products, new ideas, putting things out in the world that could eventually become actual GitHub services, right? And so I like to think of ourselves as being really good at going from 0 to 1, being really quick at creating prototypes, doing the research. We have a lot of researchers on our team, launching experiments, basically trying to get things out into the world that we can share with people to get feedback. That might be in writing, that might be a prototype, that might be something that looks a little bit more like a product. For example, I think we're most well known for GitHub Copilot. And that came out of a team at GitHub Next. So that's what we try to do. And we're a new team. We've just been around for, Matt and Amelia and I have only been working together for about a year. And the very first area that we started to explore had to do with data. Because GitHub is a great place to store code and a lot of people have data on it, but we got a sense that there were some workflows around data that GitHub just hasn't really, expanded on. And so we were wondering, how can we make GitHub and data really play nice together? And the very first project we actually did as a team, we called it Flat Data. And it's a project to explore basically how you can bring data sets into your GitHub repositories to do interesting things there, to keep versioning, to make it easier to get that data, to make it easier to scrape stuff. And we called it flat because it's basically for working with, unnested data structures. So this is going to become more concrete as we go along. There are very few slides. We're mostly going to do demos. But, first, just to kind of pose the question to all of you, have any of you had to do any of these things? Set up infrastructure or scripts to download data sets? Have you had to figure out how to use a data set in your application, right? Have you had to figure out how to track that data set and keep it up to date and maybe update it with fresh new changes? Or have you had to, for some reason, maybe you're doing some kind of data visualization and kind of showing how that data changes over time, have you had to keep track of what those changes are? And if you answered yes to any of these, then we think Flat Data could be a project that could be helpful for you. And before I get into a demo of what it actually does, we want to give a tip of the hat to Simon Willison. He's an amazing British programmer. And if you don't know him, you should check out his blog and all of the stuff he's done. And he actually, we were very inspired by a blog post that he wrote called Git Scraping, where he first talked about this pattern of sort of how you might use Git as a tool to not only scrape data, but keep track of changes in your data. And we were inspired by that. And we thought, okay, can we take this further and kind of create tools around this to make it easier to do for people? So that was the genesis of the project. So thank you, Simon. And so Flat Data is really, it's more like a workflow. It's a way of working with data and using GitHub to do that and using GitHub and Git. And we built sort of 3 separate tools to support that workflow. So each one of us is going to talk about these different tools and kind of show you how you can use them. And we're going to do a bunch of demos along the way. So let me start off with the first tool, which is our action tool called Flat Action. And so let me kind of expand my view here. Can y'all add in the chat, if you have used GitHub Actions, could you just say yes or no? Like everyone right now, like yes, no. Have you used GitHub Actions in the past? Do you know what it is? Just so I can get a sense of the level of expertise in the room around actions. Okay, a couple of yeses, couple of nos. No, but we know what it is. Mildly aware. Okay, cool. Okay, so maybe half the folks are familiar with GitHub Actions, maybe half the folks are not, no problem. So let me actually just run through a demo and this will all make sense. So you can see the screen here where I have my GitHub repository, right? Okay, so I'm just gonna do a demo flat out and we'll talk about what the flat action is. So I'm gonna create a new repository and I'm gonna call it the flat demo, okay? And I'm going to make this public so you can all see it later. And I'm just going to create this repository. All right, so we've got that here. And then what I'm going to do is I'm just going to use the GitHub Ui to do this more easily. I'm going to create a file. And in order to create an action file, and this will make sense as we go along for the people who don't know what actions are, think of them as kind of like scripts or workflows that you can run on a server somewhere. So GitHub made this tool mainly for like CDCI, right? Continuous integration and continuous deployment or delivery. But a lot of people use actions for all sorts of things, for automated testing, like all that kind of stuff. I'm going to show you what it is, but the basic building block of an action is basically a YAML file that contains all the instructions for that action. And so it's kind of a GitHub convention that you have to create these files within a specific folder called the .github workflows folder. That's just a convention for where GitHub is going to go to find your actions. And I can call this action whatever I want. I'm just going to call it flat, but this could be whatever. It could be my name. It could be, you could specify many different actions in your repository. And I'm just going to create one flat action. And I'm going to copy paste this in, and I'm going to explain what each of these things do. I'm just going to save this for a second so we can get kind of like a nicer view at what this is. So the first thing I did is I gave this action a name, and I just called it flat. But again, you can call it whatever you want. And then I specified the schedule that this action is going to run on. And so for those of you who are not familiar with a cron job, it's just a way, it's kind of a utility to schedule jobs, to use these kind of funny patterns here to schedule jobs over a period of time. This pattern in particular is saying that this action is going to run every 10 minutes. There's a lot of resources on the internet where you can go learn about cron jobs and learn about how to make these patterns. So we're saying, hey, this action should run every 10 minutes. And then the question is, well, what is the action? What is the actual job that we're running on this server somewhere? And you can see that that part goes here. We're saying, okay, this job is going to run on an Ubuntu machine, and it has 2 steps, all right? 2 steps. The first step is we're going to check out this repository. This same repository, flat demo, which has nothing right now but this file. We're going to check it out, and we're going to put it on that machine that is running this script. And the second step is that we're going to use our flat action. So what is this? Well, the cool thing about actions is that you can create your own scripts that you've made yourself, or you can go to this marketplace. GitHub actually has a marketplace. Let me show you here, with tons of different actions that you can use. So some are like CDCI actions, some are made by GitHub. Like there's all sorts of things in here. Some are helpful for running tests, et cetera, et cetera. We made our own action that we called flat data. And so, if I go back here, all that this is doing is it's saying, hey, by the way, go use the flat action that we made. And then all that you have to do is specify 2 things. You have to specify where you want to download your data from and what you want to call that file that you're downloading the data from. So just for the purposes of this demo, I went to the NASA website, and they have a bunch of free APIs. And this one in particular is pretty cool. It lets you find near-Earth asteroid information, all right? And so they have an example endpoint here. I can actually just click on it, and this is what the endpoint looks like. It gives you a bunch of information about asteroids. So, what I did is I literally copy pasted this here. This is the very same URL. And I said, hey, I want you to fetch this data, and I want you to download this data into a data.json file in my repository. So that's the action. It's going to take that data, that endpoint, and it's going to download it into my repository. So then the question is, well, how do I run this? And so for those of you who haven't used actions in the past, you can go to this little tab here that says actions. And because this is in my special GitHub workflows folder, GitHub knows that there is some kind of action there. And in this case, I'm just going to run it like this. I'm going to say, hey, okay, run my action, run my workflow. And so we can see here that the flat action, you can think of it as a script that's running in a server somewhere, is running, right? So I can go in here, I can see that the job is running. It's running on an Ubuntu machine, yada, yada. Okay, let's just wait for a second for this to finish. All right, it wrapped up pretty quickly. It fetched the data. We can see here that it's doing some stuff. It's like running this. It's fetching the data, yada, yada. And then at the end of it, the result is that we've got this data.json file in my repository. And as you might expect, this data.json has the same data. So we basically, with 2 lines, basically 2 lines of configuration, if I go back to my action, there's 2 lines of configuration here that you add, your endpoint and the data file. And just with that, you can get data in your repository. And before I hand it over to Matt to show you, a different way that you can do this, I just want to show you kind of two other sides of this, which is we built a previous demo that is downloading the price of Bitcoin. And I just want to show you that, the value of this is that you end up you can use Git to track different versions of your data, right? So this has been a demo that's been running for a long time. And so I can go in here and I can use Git just like I normally do. And now I can see the changes over time in this data set. So it just does that automatically for you because you're using Git. So that's one thing that I want to point out is this idea of like tracking data over time. We're trying to make it really easy for you to just use the primitives that GitHub has in order to do that. And the second thing is that you don't just have to use this for data sets. So NASA also has an endpoint that lets you download an image. So in this case, we created a flat data that the endpoint is actually an image, all right? And so, or it's a JSON that points to an image. And then we do some post-processing, which we're gonna talk about in a second. And what we actually save in this case is an image, right? So you don't just have to limit yourself to kind of textual data. You can do all sorts of stuff with this pattern and with this workflow. All right, so that's the intro. So let me go back here for a second. I talked about the action, and now Matt's going to talk a little about the second tool that we made, which is the editor. So Matt, you want to take the reins?
Yeah. Thank you. That was excellent. You've teed this up perfectly for me. So quick poll for the group. Who here has used VS Code, or even better, has written a VS Code extension? I'm curious to kind of see the answers fill in the chat, and we can use that as a jumping off point for showing off this demo. And I'll give some background while all the answers come in. So one of the interesting things that Simon Willison, who we owe a lot of gratitude towards for this general idea of Git scraping, one of the things he calls out is, Git is a really powerful tool, not just for developers. And you can expand that thought to think GitHub is a really valuable product for people other than just developers. You can think of journalists who are working with data in their reporting. A really good example that comes to mind is during the last US presidential election, there was tons of data visualization and aggregation of just facts and things people were finding on the ground. And a lot of that data ended up in GitHub, actually. And GitHub kind of became sort of a source of truth or a system of record for all this really cool election data. And so you have more and more people using GitHub that aren't quite developers. And so with that observation in mind, we asked ourselves, how can we make it as easy as possible for anyone to create the flat action that Irene just showed you? Now, the bar is pretty low, right? Like Irene pasted in 10 lines of code and boom, like data is getting into that Git repository fast, easy, no further intervention is required. But one of the ideas that we had was to build a Visual Studio Code extension, which I'll show you in a second, to facilitate the authoring and I guess maintenance or updating of these flat actions. So let me do a quick demo. Hopefully this all goes according to plan. I've got a couple things here. I'm looking at VS Code. I have a brand new Git repository. It has a valid upstream set. So if we go to GitHub, we should be able to see this bad boy. Actually, it's over here. Boom. So an empty Git repository, nothing in it. But if we go back to our VS Code, I have installed the flat editor extension. And this can be done through the sidebar here. We need not do a demo of that. But once the extension is installed, you can actually create a flat YAML file by doing Command-Shift-P, which pulls up the VS Code command palette. And you can see all the commands here, but we're just going to go initialize flat YAML file. And what this is going to do is give you a graphical editor that you can use to author these flat action files. So one of the immediate benefits of doing this is with regards to cron scheduling. So I could never actually write a cron statement. Like even if you paid me $1 million, I just will never understand the syntax. My mind works very, very differently. So to at least facilitate this, we gave some very easy options to say, hey, every 5 minutes, every hour, every day. But if you want to show off and be fancy because you know this kind of stuff, I'd love to talk to you afterwards if you do know. We built this little widget that'll actually show you, hey, as you type things here, it'll tell you, oh, this isn't valid cron, or wow, you're really, really good at cron, and it'll validate all that stuff as you type. But as I'm doing this, I can't even figure it out. So yeah, it works like that. Pretty cool little widget here. And we also link out to a place to actually teach a cron. So fun times. But if we go back to the extension, beyond that, we give you the ability to add as many flat data steps to your action as you need as per whatever data fetching needs you have. So to get started at the simplest level, to replicate what Irene did, I can hit add from HTTP, and you'll see very similar fields to what Irene had put in her initial flat YAML. So if we follow that template, we put in our lovely NASA endpoint URL here. We tell it what file it wants to download. And you'll note it's actually giving you a little preview of this data contextually, just to say, okay, is this precisely the data that you want, just as kind of a gut check to make sure that you're doing the right thing. And moreover, if you do have one of those post-processing files, which we'll get into in a later talk, or later bit of the talk, you can reference that file here, and the action will call this post-processing file as the action runs. So one other facet that I wanted to show you all, which was not covered, was we actually support fetching SQL data as well. So let's assume for a second that you have a SQL database out there on the web, and you want to write a query against that SQL database on some kind of schedule. Well, this immediately poses a big problem around security, right? Because we don't want people to just write arbitrary queries to your database. Like, that's bad news bears. What we've built out is the ability to not only pass through a query file that you want to execute, but also store a secret connection string that'll allow us to actually connect to that SQL database and execute that query as a GitHub secret. So in GitHub, there's a part of the UI that you may have poked around with called Secrets. So if you go to settings for your repository and you go down to secrets and you go to actions, here you can actually create secret values that can be used in the context of your GitHub action. So think of this as an API key, a connection string for your SQL database. And when you create these secret values here, this is super secret, by the way, don't share this with the world. Hello, 1, 2, 3. You can use this value in your template YAML, which is really, really nice. So you don't have to worry about leaking credentials or leaking secret values to the world. But anyways, the SQL workflow is very similar, right? You pick the query, you tell us where you want to download the file, you give us that secret file, and you're really off to the races. But just to show you that this isn't all hocus pocus, you can actually see the raw YAML by going up to the top here and seeing view raw YAML, and quickly get that gut check that the file was serialized correctly and that the UI didn't do anything funny to your actual data. Now, the last thing I want to point out, just as to kind of show off the value of using the graphical interface, is we love building VS Code extensions for the obvious reasons of UIs can sometimes facilitate complex workflows. But one of the tricky things about VS Code is everyone has their favorite VS Code theme, right? Like, I cycle through 10 different themes in a given month because I see the latest on Hacker News or Twitter. So one of the challenges was getting this UI to look good across various different themes. And so we're using a library called the VS Code UI Toolkit that ensures that all the rendered UI components, the text fields, the radio buttons, the primary buttons, all correspond correctly to the actual syntax highlighting theme that's being used by the end user, just to make sure there's no weirdness or no wonkiness as the user cycles through themes and goes through this workflow. So that was a fun feature to build out, and I will share a link after I'm done presenting for that particular that library. Amelia, Irene, have I glossed over anything about the UI here?
No, that was wonderful. I also wanted to mention something that might not be known is that this is just a web view. So this is basically just an iframe. I think it's a double nested iframe of a website. So that's why it's super important, because you don't really have any primitives when you're dealing with these web views in VS Code.
Totally. You can see I can just poke around here and use the inspector to debug a literal, to Amelia's point, it's an iframe running some React. So if you know how to write React, if you know how to write HTML even, you can build one of these iframe web views and build really powerful graphical interfaces for whatever particular tasks you want to put in front of a user.
Which,
cool.
As a web developer, I love.
Yeah.
All right, so I can demo the third part of this. All right, demos. So basically, the third and last tool that we built to support this workflow is something that helps you make sense of your data. And last year I worked at The Pudding. They do a lot of like data-driven articles. It's kind of similar to what the New York Times does. And there's a lot of people I know who are journalists who don't necessarily code a lot, but they still deal with data. So there's a lot of ways that people could put data into GitHub, but making sense of that data is really important. So we wanted to kind of smooth that path where like you might have a CSV file, but this is a little bit hard to read. And then it's just kind of sitting there. So this demo is something, it's just a simple one that converts an Excel spreadsheet into a CSV file. So you can see that here. So the last thing we built is we're calling it Flat Viewer. So if you prepend flat to any GitHub URL, it'll take you to our website, which basically goes and finds all of the CSV or JSON files within that repository, and then puts them in a view that's just a little bit easier to read. So for this one, it kind of just makes it searchable, which is nice, but there are other ones. So here's one looking at flights, so we can flatify it. There's also, we add a histogram that's filterable. So you can see like for these flights, are they kind of spread out equally across different days? And you can also filter based on, I only want to see the latest day. And we definitely got a little bit fancy with it. So this repo is basically most of the data sets that the pudding uses for their articles, which they awesomely put on GitHub. And so if you flatify that, you can look at all of these. They had an article about boy bands. And we added a bunch of really fun, we went a little bit crazy with making a spreadsheet in the browser. And you can also change which commit. This one only has one commit, but if it had history, you could see how it changed over time. So there's some fun things here, like this is a heat map. So darker colors are later and lighter colors are earlier. And you can kind of see it's highlighting the bars up at the top in the header here as I scroll over different rows. We also look to see if something's part of, if there's like a limited number of strings within a column, and then we surface what those categories are. You can click URLs. So we went a little bit crazy with it, but it's been super helpful just having this spreadsheet view for any data set that you might have on GitHub. We also render colors. That was a recent addition. That's kind of fun. So this is something that we also open source called Flat UI. And we've also open sourced it as a React component. So we both have this website that you can use to view any data on GitHub. And we also have the Flat UI component that you can grab and throw in any React app that you might be using. And we've actually used it ourselves quite a few times. And you basically just have to pass it data, which is an array of objects, and it'll create that view for you. And I know some people have been using it on Observable. If you're familiar with Observable, this is just an example of like, hey, it will work anywhere where React works. So please use it. We put a lot of love into it, and it's also open source. So let us know if you want new features or if there are bugs, which does happen. All right, so those are the three tools we have. Actually, this is our write-up. So up at the top, we list them out. We had that action that Irene demoed. We have the editor that Matt demoed. Then we have the viewer that I demoed. And hopefully you can kind of see how the project isn't the tools. It's more spreading the knowledge and empowering people to use this workflow to bring their data into GitHub, and hopefully a few tools to smooth your path along the way. And we have this diagram of what it might look like. So you might pull in from different data sources. Within your repo, you have this data JSON file or whatever you choose to call it. You might have some post-processing script and then have some processed JSON or an image. And then to bring that out of GitHub, we have Flat Viewer. There are some other examples. We'll show a way to put that into an app a little bit later. You can throw it into a database. And then we have a few demos in the write-up. So like for this Bitcoin prices one, it's hitting a Bitcoin API, processing it into this post-process file, and then you can view it in Flat Viewer. There's a few other fun examples in here. And if you're looking for more inspiration, You can also, this link is in the presentation. I can put it in here as well. And these are just our demos of ways you could use it. And there's a lot of different ways you might use it, permutations of what APIs you hit, how you post-process that, how you might turn that into something actionable. So definitely check this out if you're looking for inspiration. And then I guess I'll just dive into, we were gonna do a demo of the whole thing all the way through. I haven't really practiced this, so please be nice to me when it ultimately fails. And I promise you it will. Our goal is, one of my favorite data sets to play with is weather data sets because they're so rich. So our goal is to have this kind of view of weather in your area. And this is a 16-day forecast. So you can have it run every day and then build a dashboard on top of it to, you know, have whatever weather you're most interested in and have a dashboard for yourself. All right, I will just do it. So the first thing to do is to create a GitHub repo. So let's go to my personal GitHub. And we'll make a repo, new repository. This is going to be flat weather demo. And let me know if my text is too small or anything. We'll make it public. We'll create the repository. Boom, new GitHub repository. We're going to copy this SSH git link, go over to VS Code, clone the GitHub repo locally so we can work with it. And I'll just throw it in my personal repos folder, open it. All right, so good so far. So I already have flat editor, I think is what it's called, flat editor installed. So I can go ahead and say flat editor initialize flat YAML file. So this brings up the editor GUI VS Code extension. All right, so every day sounds good to me. It's a 16-day forecast, so that shouldn't update any more frequently. I'm going to move the zoom bar, and we want to add an HTTP endpoint. So sure, let's throw this in data.json. We need this URL. So we found this 16-day daily forecast from openweathermap.org. It's free, you just need an API key. You have to make an account and then grab an API key, which we'll see in a second. So we can grab this URL, paste it in here. Actually, probably this. And then there's a few things we need to fill out. So there's a latitude, longitude, how many days we want. That one we know, it's 16. I can use my cheat sheet here because I already looked up the Brighton latitude and longitude. We can throw that in here. And then for our API key, we saw before how we can add GitHub Secrets into these different strings. So the way you do that is you just have this kind of syntax, and let me just copy it here so I don't mess it up. So if you do anything within double curly braces, it'll basically execute that within a GitHub action. So here we can create a GitHub secret within our repository, which I think is right here. So if we go to settings, secrets, and it's going to be an action secret, I'll create a new one. It's going to be called API key, and I'm going to change this right after this recording, so nobody is querying the weather API on my dime. I'll add that secret. So now whenever this this action runs, it'll be able to grab that in here. And then we also have some fancy parameters on our flat action GitHub action. So if we go over here, this isn't actually documented. Actually, it is documented, but it's not in our editor. So we're going to have to put this in manually in the YAML file. So this will actually mask the API key. So there's some debug statements when this action runs. So if someone looked at my public repo and looked at the logs for when an action runs, I don't want them to see what this API key is. So I can put this in a mask, super secret. And then the last thing we want to do here is add a post-processing file. So I already wrote this. It would be really boring if I were to write this again. Let's go ahead and add this here. What did we call it? Process weather. It's a TypeScript file. And this is actually a Dino. I don't know how you're supposed to pronounce it. A Dino script. So you could run this from the command line, just doing like Dino run, and then you have the script name. We want this.
I can also jump in here, Amelia, just to give some color as to why we chose Dino. We knew that we wanted to give people the ability to post-process their data, just because there's any number of reorganizations, remappings, transformations that you might want to do. And the only sort of zero runtime approach we could find without having the user have to install node modules or set up like a Docker image or just like really unholy things was Dino, where you can quite literally import modules via URL, as Amelia was showing in that script, which is really, really nice. And then to Amelia's point, you get this really easy script you can run straight from the CLI and see the output before you ever commit it back up to GitHub. So it's a pretty cool tech if you haven't checked out Dino yet.
It is. We none of us had used it before we made this, and after playing around with it, we're all really big fans. So you could run it from your command line like this, but you need to input the data file, which we don't have yet. So it would work, but it can't find that file. And basically what this file is doing is it's grabbing that raw data and like throwing our own emoji on it, parsing it. You could really do anything you want within this script. But this is what we chose to do. All right, so this is all set. Let's go ahead and commit these. Just do a init. And then now if we go to our repo here, we should see it at least. Probably need to push. All right, there we go. So we can see both our action YAML file here, where what we're doing is we're setting up Dino, we're checking out our own repo, and then we're fetching the data from this URL, downloading it to data.json. We're masking our secret for super max secrecy, and then we're post-processing it with this TypeScript file. So I bet you if we go over to actions, we'll see it running. Actually.
Sorry, Amelia, let me jump in. Can I jump in and answer a question that came up in the chat? So someone is asking, can I call a serverless function directly, or do I need to use Dino as an endpoint? So let me clarify here. Think of Dino or Dino as an alternative to Node. So it in itself is not a serverless function. It's not an endpoint. It's just kind of a runtime environment. So the way to think about it is that the link that Amelia had, that is the endpoint. And the first step is that the action is just downloading it to your repository. So you can just do that, like I showed in the first demo, and you don't have to mess with Dino at all. Dino is useful only if once you have that data file in your repository, only if you want to do something to that data file. And then what happens is that because the action is running in some server somewhere, that server itself is running kind of like the Dino script. So think of it as running like a Node script that takes in that file, does a bunch of stuff, and outputs a new file. Let me know if that answers the question.
Thank you, Irene. Yeah, it can be any endpoint or SQL database. So we can see this URL is going to return this list of data. This isn't necessarily the way we want it to be formatted. So we took this and we run it through this post-processing script. And what we're going to get is a flat array of all of these parts of the weather data. So hopefully that's been running in the background. Something horrible has happened, of course, because this is a live demo. Yeah, we are not sure what happened, but we're just going to run this again and cross our fingers.
Aren't live demos fun?
Oh, mask. Oh, I think you have an error with the mask parameter. Can you actually just use mask is true? I think that should work.
This should work, I think. We'll try it one more time and then we'll take it out because everyone's seen my API key anyway.
Yeah.
There's no secret here.
Yeah. I think if you use just masking true, we changed at some point. Oh, post-process error. Let's see.
Okay. Yeah, unclear. It also, yeah, sometimes we get these weird ref errors with GitHub Actions. I can do it one more time, but also we have this already done. Always have a backup. So we have this, where's my chat? We have this repo already where it's been running very successfully. I shall add. And the cool thing about this is, so we have this data process JSON file. So if we look at that, we can see this within our flat viewer. We can also see how hard it is to look at that unprocessed data set because it's nested. But the cool thing about this is, so within a repo, you can do whatever you want with the data, and we wanted to demonstrate what you might build on top of it. So we have this super simple Next.js React app, which deploys whenever the data updates, and it's just taking that data and displaying it within a little dashboard. So here's that dashboard component, and if we open up our website, this is just on GitHub pages, we can see like whatever other view you might want to see about that data. So maybe you want to run analyses on it, you can display the results of those analyses, have something interactive, show one direction with an arrow. You can, the web is your oyster. So hopefully this demonstrates all of the crazy things that you could do with flat data. Really the limitation for us was our imagination. So
one, if I can jump in, Amelia, because I think this is like an awesome segue. This kind of application really gets me excited as a front-end developer. Like in my side hustles, I do a lot of work with headless CMSs where we're building Next.js apps that pull data from this CMS or that API or that whatever. In this regard, flat data can be a way to ingest data to power a front-end website. It can be a marketing site, it can be an internal dashboard, it can be whatever. And on top of that, you can do really cool things like the data that Amelia was pulling down from that weather API has a tight schema, right? Well, what if you used a flat processing step to generate TypeScript interfaces for that data set and co-located those in your repo so that when you went to build your front end, you had all the TypeScript interfaces there ready to go and you didn't ever access the wrong fields on objects and things. It was just automatically like prepared for you. So we've seen a lot of really cool applications of this on the front end side of the house. And we're certainly curious to see what you all come up with in terms of taking data and kind of rearranging it into a better shape for development.